So, as per this problem, two swimmers leave a point A on one bank of the river and reach the other point B lying across the river on the other bank. So, it's directly opposite to point A. So, had both the swimmers picked up the same path while crossing the river, we would not be solving this problem. We would be solving some other problem in this time. So, it says that there are two swimmers, S1, let's call them S1 and S2, who have attempted to cross this river and succeeded. But both of them have taken different paths. Irrespective of that, the problem says that both of them actually reach the point B in the same time. So, let's consider that this is the direction of the river, which should be VR. So, let the velocities of the swimmers be Vs. So, let's consider swimmer 1. Swimmer 1 has moved from A to B in the direction of that is perpendicular to the direction of the river. So, commonsensically, this says that the river velocity would push the swimmer A away from this straight line which he intended. So, he would actually reach the other bank at a different point, this point P. So, let the distance between B and P be x. So, this is his river, his velocity of the swimmer, and this would be the velocity of the river. So, this is the push which he has actually got. Okay. So, in this manner, if you see, there is a net displacement x which happened purely due to velocity of the river. He is supposed to reach here as per the direction which he intended. So, it's a straight line. So, there is no horizontal component for his velocity because the angle is 90 degrees. So, if I have to take any horizontal component which has been because of the swimmer's velocity, it will be 0 because V cos theta in this case will be 90 degrees. Will be 0. V cos 90 would be 0. So, the displacement x is technically because of the velocity of the river. The other way, if you see, let the distance between the two banks be d. So, the entire displacement is purely because of the velocity of the swimmer and not the velocity of the river. If you see, the velocity of the river is completely in the horizontal direction. So, there is no component in the vertical direction. So, if I have to see how much time the person S1 has taken to reach point B, his motion would contain two parts. One is point from A to P and P to B. So, for A to B, so the net displacement from A to B would be d. And the time taken, let it be t1. So, So, with the relation between d, t1 and vs, because we already discussed that the movement from A to B, the velocity was purely vs because there is no vertical component for velocity of the river. So, the relation between them would be d equal to t1 into vs. So, reordering the terms, we get t1 is equal to d by vs. So, this is one component. So, the other component would be the person moved from A to P. So, this is net displacement of x which is because of the velocity of the river. So, but it would be the same time because of the displacement is still d in this case. So, x is equal to time t1 into, we discussed that it's purely because of river velocity because there is no horizontal component for the swimmer's velocity. So, if I had to substitute t1 in this, what I would get is that's equal to d into Vr by velocity of the swimmer. So, this particularly has been done in order to establish the relationship between the time and the distance x in terms of known values. Okay, so you will get to know why we did that. So, the other component is movement of the swimmer from P to B through a distance of x. So, we come to know that he has walked with a velocity of u. So, he has a velocity of u, displacement is x, and the time taken for this would be t2. So, t2 will be equal to x by u. So, substituting the value of x which we got here. So, just like we substituted the value of T1 in this equation. We'll substitute the value here in the below equation. So we get d into Vr by u into Vs. So the total time taken by swimmer S1 T would be equal to T1 plus T2, which would be equal to T1, which is d by Vs, plus d into Vr by u into Vs. So this would be equal to, if I pull out d as a common factor, d by Vs as a common factor, it will be equal to 1 plus Vr by u. Okay, so this is the first equation which we get. Now let's go ahead with the second problem, with the second swimmer. Okay, the problem states that the second swimmer has reached directly from point A to B. So technically speaking, if he has reached directly, so he had swam in such a direction that has countered the horizontal component of the velocity of the river. So he swam with the same velocity Vs, but it had a component which is horizontal, which would be, in this case we'll come to know that, which would actually counter the entire velocity Vr. So the net velocity he had in this direction from A to B would be only the cosine of the angle between the direction the swimmer has taken with the line A to B. If this angle is theta, so the velocity which was there for the displacement A to B would be Vs cos theta. And of course displacement is d in this case, let the time be t3. So if I have to represent this particular triangle AB, let's put a hypothetical point P dash. AB P dash, forgive me for lack of straight lines. So this is B, this is 90 degrees, this is A, and this is P dash. So this angle is theta here. This is Vs, this is Vr. So this particular value would be Vs square minus Vr square. So of course the square root part. Okay, so going by this particular value, T3 would be equal to d by Vs cos theta. We have seen why it is so. It is because only this particular component of velocity of Vs, this is the other velocity which has countered Vr, this would be Vs sin theta. So this has been nullified. So only this particular component, which is Vs cos theta, has been used to traverse this distance d. So cos theta, cosine of theta would be adjacent side by hypotenuse. So I'll just put it up for you here. By hypotenuse. So getting down, we get T3 equal to d by cosine. Adjacent side is root Vs square minus Vr square divided by hypotenuse Vs. So this would be equal to d into Vs by root over Vs square minus Vr square. This is because we get this thing to the top. Okay, something seems to be a miss. Oh, sorry, I missed this Vs component. I just added cos theta here. I forgot to multiply by Vs. So we'll have to multiply the denominator by Vs. So which would actually result in this and this being cancelled. So this doesn't exist here anymore. So T3 will be equal to d by root over Vs square minus Vr square. Okay, now solving this particular problem, let's try to use this space. I don't think we'll, let's try. Okay, so since we said like the total times are equal for both the people, so t equal to t3, So it would be d by Vs into 1 plus Vr by u will be equal to d by root over Vs square minus Vr square. So d and d cancel out. So now if I have to substitute all the values that are relevant here, velocity of the swimmer is 1 by 2.5 into 1 plus 2 by u equal to 1 by 2.5 square minus 2 square. So this would be equal to 1 by 1.5. This particular component would be 1.5. You'll have to work it out yourself. Let me try to see if I can fit it out here. So what I get here is 1 by 2.5 equal to, sorry, 2.5 equal, sorry, 1 by 2.5 into 1 plus 2 by u equal to 1 by 1.5. If I do a cross multiplication, 2.5 would come here. So then 1 plus 2 by u is equal to 2.5 by 1.5, which is 5 by 3. So this implies 2 by u will be equal to 5 by 3 minus 1, which is equal to 2 by 3. So net is u is equal to 3 kilometers per hour. So that's we are done it.